Dit. Come in, Jack and Brian. This is Mike Brown, self-proclaimed EVTV Southeast Asia correspondent, and I'm reporting in from the Electric Vehicle Trade Show in Taipei, Taiwan. This will probably be a one-time video submission for me because I don't have an active project. I just wanted to come to the show and see what the electric vehicles and components activity is like in this part of the world. This isn't going to be fancy, no intro music. I'll be lucky if I can edit the clips in order and put a couple of still picture overlays to show what I'm talking about. I see you've been getting short shift lately from some of your correspondents, so I figured I would do this and go ahead and air it if it's good for you. Before I hit the show floor, let me briefly, or not so briefly, explain how I come to find myself here. I made some notes so I can sound relatively coherent. Some people may remember me from the first two EVTV conferences. I missed the third one because I was moving overseas, but I'm already signed up for the fourth one, and I'll be happy to see everyone there. My electric 914 is car number 84 in Jack's EV database, and I've literally watched every second of EVTV, including the epic battery testing sagas. So I'm a long-time fan, first-time caller. And as with a lot of your viewers, I was in the computer industry. I have degrees in software engineering, worked for IBM for 22 years, and all of that consulting took me around the world. I've been to 46 countries, and Taiwan makes country number 47 for me. And I knew Fred Veining pretty well at the briefing center in Austin from my customers that I would take over, and sometimes I would give a talk there too. But neither of us had the electric bug at that time. So my interests in alternative energy and electric cars had been simmering for a long time, but I didn't act on anything specific. And we were living in Australia in 95 and 96 when the EV1 was launched, and then slowly fell apart, so I missed all of that. And I went to a showing of Who Killed the Electric Car at our local Springs movie theater, and there were several converted cars and pickups in the parking lot. And that started to get me thinking seriously. So I became a work and travel from home IBMer when we moved to Paso Robles, California in 2008. And that should ring a bell for Brian because Paso has over 250 wineries, and we're in heated competition with Napa. And we did our best to take advantage of the situation there, including our favorite winery called Graveyard Vineyards. And they offer a dessert wine among their other award-winning wines called Deliverance, which is infused with 3 kinds of chocolate liqueur. It's really good. On the day I closed on my house in Paso, I contacted a local solar power company called REC Solar and told them to start engineering a big system for me. With the flexibility of 2 acres of land out in the country, we decided to make it a ground mount because the house was pointing in exactly the wrong direction. And I wrote a Java application for my website that collected the raw data from the inverter and displayed instant and historical power generation data. And I discovered I was making about 78% of my total consumption needs, including a lot of air conditioning, all my computers, a full woodworking shop, and eventually charging my electric car. And the first year, my entire 12-month electric bill was $278. So it really pays off. So a year later, I decided that I liked the solar industry so much I quit IBM and joined REC as the monitoring engineer. Did that for about 5 years, and then everything changed. And I'll get back to that in a minute. In September of 2009, I decided I was going to build an electric car. And I started a blog at Porsche914e.blogspot.com to document the process for myself and also to help other folks coming down the line, to help them see the choices I made and how I did my work. I decided on the 914. It's a popular choice because of the huge battery capacity space and also the availability of a kit that would get me up and running quickly. So I didn't have the knowledge at the time to pick the right parts and fabricate everything needed, like the battery racks and battery boxes and adapter plate. But I'm really good at following directions. So I went with a kit from Electro Auto. In hindsight, the kit is really well engineered and complete, although it's based on a system with 20 lead-acid batteries. Sorry, I hadn't discovered EVTV yet, and the lithium-ion price was just a budget buster, so I figured lithium would be version 2 of the car. It was a DC kit with a Warp 9, a Curtis 1231C controller, machined adapter plate, taper lock, battery mounts, battery boxes, spools of wire, dozens of bags of hardware, copper battery bus bars, gauges, contactor, 100 other parts, and a really good, complete manual. But the only disadvantage was they took my check and I didn't hear anything from them for a year, despite phone calls and emails. Luckily, I only lived about 4 hours away from their house, so on a Saturday morning I drove my pickup truck up and asked them to give me all the parts they had. And so they scrambled around, filled up the truck, and I went home with the promise of getting the rest in short order. As for the car, I bought a 1973 1.7 liter off of eBay. The ad said looks good from 10 feet. And I picked it up for just over $4,000. And I had a buddy drop me off in Stockton, and I drove it home. It worked great as a gas car. The description was fair, but once you get up to about 9.5 feet, you start seeing the problems. Rust, and more rust. And the best one was there was a small primered section just behind the passenger door handle. And when I started investigating it, I found that someone had filled the hole with bathroom caulk and done a little primer over, or a Bondo over top of it, and then sprayed it with primer. So with a sigh, I stripped everything off the car down to the bare steel and took it to a body shop in town called Rainbow. They were recommended to me by a guy who had them work on his real 356 Speedster, so I knew they could do a good job. They worked on it for about 6 months between insurance jobs and gave me a really great hourly rate for a project car. They blasted it down to bare metal, fixed all the rust, pulled out all the dents, primered it, and painted it in Meteor Metallic Gray, which is a current Porsche color that I saw on a turbo one day and decided that I really liked. And I kind of modernized it by removing a lot of chrome and the vinyl across the T-top for a more modern look. So with the car back and most of the parts in hand, I started on the rebuild and restoration. And I restored every nut, bolt, washer, rubber, and electrical thing in the car. If I was going to make an electric car, I wanted one that didn't look like a piece of junk and reinforced the public's stereotypes. I did take a few liberties with the design by upgrading to modern fuse blocks because the original one just scared me. And I put all the controls and everything inside NEMA-rated waterproof enclosures with transparent covers and gland nuts. And the kit came with a 120-volt charger, so I added a 120 to 240 toroidal transformer, the AVC1 board from Modular EV Power, and a J1772 plug so that I could do both household charging, opportunity charging, and public car charging station charging. And it's not a lot of current, but the pack was small, so the occasional top-up or overnight charging was fine for me. So being a data junkie, I wanted to collect everything that I could out of the car as it's rolling down the road. So I went with a system called Pack Tracker. I wired up each of the batteries to it and its Hall effect current sensor, and then I wrote an Android app for my phone, which I tied into Google Maps and the GPS. So it would show you where you were going on the map, and it would keep track of your range dynamically and your trips, and had big gauges for percentage of charge remaining, voltage, temperature, current, and a graphical battery layout showing the individual voltage of each of the batteries in the pack, along with any warnings or errors that were caught by the Pack Tracker. So just as I finished the software and posted it to the Google Play Store for 99 cents, called of course Pack Tracker for Android, the one-man Pack Tracker company went out of business. I offered to buy him out and continue development and sales because I had circuit board design and embedded software experience in my distant past, but he said it wasn't worth his time to teach me everything I needed to know. So that Pack Tracker hardware is now a dead end. I did end up selling about 20 copies of the app, including 2 guys from Sweden and a guy in Virginia with a gorgeous catamaran with an electric maneuvering motor. So with my lead sled rolling, I was getting about 40 miles on a charge, which was great for driving around town on the weekends. I took it to several car shows in town and an Earth Day event and showed it off, and I even won a first place trophy for best in class called Special Interests. I don't know what that means, and I don't know who I was competing with, but I will take it. I also ran the car in an autocross put on by the local Porsche club, and when I joined the club at a different car show, they congratulated me on being a new Porsche owner and asked me what kind of car I bought. I said I bought a 914, and they said, oh. Then I said I was going to convert it to electric, and they said, oh. So I was written up in the local club newsletter at the launch and the completion of the project. At the autocross, of course, I came in dead last, but I was only 7 seconds slower than a 930 turbo with the big whale tail. Clearly, the turbo wasn't being driven to its limits, but I'll take that any day. So in September of 2012, after what Jack would call a heroic 15-year battle with Huntington's disease, my wife passed away. And at that point, I kind of had to figure out what I wanted to do with the rest of my life. So I sold everything I owned and moved to Thailand. I've had great jobs along the way and invested well. So I have enough money to live in Thailand for the rest of my life. Now I don't have Jack Rickard money, but I'll get by. I came to Thailand just with a suitcase of clothes, my laptop, and an acoustic guitar I made, and settled in a little town called Hua Hin, which is about 4 hours southwest of Bangkok on the Gulf. Beautiful sandy beaches, jungles, great food. And the king and queen live there, so there are a bunch of extra rules in place that keep the town nice and calm and quiet, as opposed to the kind of debauchery that you find in Pattaya or Phuket. So I sold the batteries out of the 914 to a local golf cart shop in Paso and put it in storage in an airplane hangar underneath the wing of a little Cessna. And there she sleeps. One of my new friends in Hua Hin, Abel, has converted a Toyota Yaris to electric drive. Talk about a small world. I found him by Googling electric cars Hua Hin, and it turns out he only lives about 3 blocks away from me. He also rents electric bicycles from his guest house and is building a ninja-sized electric motorcycle by scratch, welding it all together. His website is evspeed.webs.com, and I'll be porting my Android app to his chosen hardware board, which is spelled IOIO, but it's pronounced Yo-Yo, which should be fun. We've discussed the Arduino concept, but we'll stick with the Yo-Yo for version 1. A couple of months ago, Abel got a free ticket from one of his parts vendors for the show, so he wasn't able to come, so I grabbed the ticket, and here I am. Okay, so what's the state of electric vehicles in Thailand? None. Well, I've heard there's a Roadster, Tesla Roadster, in Bangkok. I don't know how he got it in the country, and I don't know how he's driving it on the road, because it's not legal. Just to import a car into Thailand, you get slapped with a 300% tax and import duty fee. And that 300% is on whatever value they decide to assign to your car when it's sitting at the dock. Nudge, nudge, wink, wink. This is Thailand. There's no telling what's going to happen. And there's no classification for electric road vehicles in the country. The Nissan dealer that I went to in town has never even heard of a Leaf. I did find an electric golf cart shop, and they also sell electric motorbikes like we see at the show here, but you can't drive them on the roads. For converted cars, like what Abel did with his Yaris, there's some mythology about having a government-approved electrical engineer inspect your design and the build of your car, and Abel's working through those dragons right now. So let's take a walk around the show and see what we can see, and I guarantee we're going to bump into an old friend of the show. Here we are at the show. It's actually 4-in-1 electric vehicles, motorcycles, auto parts, and auto electronics. There's about 500 booths altogether. I think about 100 of them are electric vehicle related, which is straight ahead. And I'll kind of walk you through and show you some of the interesting booths. So this booth is a Taiwan Automotive Research Consortium research group, and they've got a demonstration hybrid car here, and they've got a floor-mounted battery pack with green ice lithium batteries, and I'll show you that booth in a little while. And you can also recognize our favorite Brusa charger in the back. It's pretty much just a rolling prototype as they do basic research and then do technology transfer to manufacturers. Okay, so I'm here with Jackie from Changhong Battery Company. Changhong, thank you. And he's going to explain his lithium battery technology to us, starting with the pouch cells.
Hi everybody. So let me introduce my battery to you all. My company is Changhong Energy Technology, and the location in middle of Taiwan, the Holy. Okay. Now you can see my product. This is we call polymer cell. Each cell is a 3.2 volt and 17 ampere hour, and you can see it's a laminate.
Yes.
Okay. And we have to keep the wear consistency. So that's our key component. All the production. For the key component, we have keep the wear consistency. Then we put the three together in parallel, and by welding, you can see the top cover.
Okay.
Okay. So the module pack. So we have final is for one piece is a 3.2 volt and 50 ampere hour. That's our one product, one spec.
Okay.
So we will keep the mass production for the cost down, and we can keep all the quality in the wear control by the same tools, same equipment, and the same quality control.
Okay.
So that's our standard product.
Okay. So, and what's your quantity pricing on the market these days for this battery?
Okay. For this product, we have selling is 2.5 per ampere hours US dollar.
Okay.
That means per piece is about 125 US dollars.
Okay.
But it depends the quantity, the cost will be done.
Yes. Yes.
Okay.
Sure.
And so far now we have the biggest production line in Taiwan.
Oh, okay.
We have by monthly we have about maybe 10,000 pieces per month.
Wow.
That's only one line.
Yes.
If a whole line for production, we have 2.5 million ampere hours per month.
Okay. Okay,
So
that's a
trust
lot.
me, you got it point. We are the best one.
Yeah. Very good. Very good. Thank you. And do those also have the A123 cells inside?
Yes, of course. Yeah.
Okay. So the same form factor cells are in that pack.
Yeah, I can show you.
Yeah.
These more pieces.
Right.
Yeah.
So if we look at the little ones, you can actually see their A123.
A123. Yeah.
Yeah. 26650 form factor. And you say that these are actually manufactured in America and shipped here.
Yeah. And because they got a patent, worldwide patent. This have a worldwide patent, 2 years. Still, after 2 years, it's free.
Okay.
Worldwide, will cost down.
Okay. Okay, here we are. I found a company with a booth that makes Jack's favorite battery strap up there, braided battery connector. And I'll let the gentleman from the company introduce himself and talk about their technology. Okay.
Hi everyone, my name is Paul. I'm from Sino One. Yeah, let me introduce our product.
Okay.
We can take the customer request. You can bring us the drawing, and we can do it customize the items.
Okay.
Yeah.
So those blocks of metal on the end are welded onto the straps.
Right.
Okay.
Yeah.
Okay. Now, if a customer wanted a specific style,
Yes.
how long would it take for you to prepare the order and send it back to
It will
them?
take about 1 week.
Okay, well that's pretty fast.
Yeah, for produce, and the minimum order like 100 piece
Okay.
per item.
Okay.
Yeah.
And do you have an idea what the price might be?
Price depending on the how thickness of the item.
Okay.
Yeah. $10.
$10
Yeah,
per
$10,
strap.
yeah.
Okay. Even at the 100-piece quantity?
100 piece will
Yeah.
be less.
Okay. Yeah. Yeah, because once you get your tooling set up, it's cheaper just to make a whole bunch of them. Okay. Because the straps that are sold, they do thousands of them, but at different distances based on the size of the battery. So we have to do that.
And we welcome the small quantity order.
Okay.
It's no problem. From the beginning,
Okay. All right. Okay, I came across a booth with spotted our favorite orange cable. So I'd like to introduce the company, and they can describe their technology and the cables that they produce.
Yeah, I'm Jeffrey from Wuxi Xinhui Wire and Cables. We come from Wuxi, China mainland. So here is our product. It's EV cable. This part is the big one. Is EV charging cable. Here is used for the charging connector to the electricity to the car, and this part is high voltage cable. And we passed the TUV certification for Euro market, and Europe. For the American market is the UL certification, and for the TUV certification we are the first of the world passed the certification.
Oh, okay.
Yeah, and for the material is TPE is very flexible, very flexible and so soft. And our customers is about like connector company TE, Amphino, Phoenix, and MC, and so on. In China like Baspa, KNT. Yeah, for the whole car company, we cooperated with the in China BMW and JAC and BYD and so on. So I think in the future we will sell better because we have passed all the certification and the good quality. Yeah.
Great. And I notice you have the two kinds of charging cable or high voltage cable, the plain and then with the shielding.
Yeah, it's want to let the hertz wave out because it's different. You see, it's used in the car to connect the battery to the motor. Yeah.
Okay. Yeah, we've used both kinds in the past.
Yeah.
And I think it's good design to use the shielded cable to reduce the electrical interference in the car.
You're right. Yes.
Is that what this style is? What the major car manufacturers always use, the shielded style?
Yeah, a lot of customers may use this more, but it's more expensive.
Right.
Because the best quality and the foundation.
And how would someone go about buying your cable? How to buy your cable? Do they buy it by the meter or by a spool or?
Some customers buy drums, like 100 meter one drum, and also they buy the cable with connector or terminal together. So
so you can pre-install the charging connectors.
Okay. The connector with the cable together, like the cable assembly. Yeah.
Okay. And then just a little detail on these cables. This is for the charging stations.
Yes, right.
And there's several different styles available with current and
DC.
Right, AC, DC, and then data flow also.
Right.
Yeah. Like this one here has some low voltage data cables built in. Okay, well, thank you very much. Appreciate your time. Okay, we are now at the YT Stable Technology Corporation booth, and I'd like to thank them for providing a ticket for me to come to the show, because they're the providers of the pumps that Abel used in his Yaris conversion, and they sent an email offering a ticket, so that's why I'm here. I'd like to introduce Bernice Wu. She's a sales executive for the company, and she's going to tell us about their water pumps and vacuum pumps. Good morning. Is a single one all by itself. Great. And coming around the side, Jack may recognize this Aurora inverter as the big brother of the one he's got on his workshop at home. Aurora is the brand for Power One. Power One was bought by ABB. So this Trio version is their 3-phase inverter line now. Okay, so I'm here at the Master Hold booth, and they've actually productized Jack's idea about lithium battery packs for golf carts. And you can see in here they've got 4 packs bolted inside the seat, 48 volt, 80 amp hour system. But the key ingredient they've added is data transmission back to the kind of golf cart control center through a Zigbee device connection. You can see the Zigbee device ID for each golf cart, and then it updates the last time it read data from the golf cart and the voltage for each of the 4 packs. You can also click the detail button, and it gives individual voltages for all the cells inside the pack. Hello EVTV viewers, I'm here at the Renaissance booth with Tim, and he's got a very interesting motor that I'd never heard of before, and he's going to tell us a little bit about the technology behind it. It's called a switched reluctance motor, and you'll see there's a small one here, and it's got 6 control cables. And then the other side of his test bench, he has a normal 3-phase AC motor that's acting like a generator and load during the testing. So I'll get Tim to explain a little bit about the features of the SR motor for us. Okay.
Hello, my name is Tim, and we are making a demo set for doing hybrid electric vehicle or electrical vehicle motor driving control system. And as you can see, SR motor is a main driver for electric vehicle. And the SR motor's advantage is the rotor is a silicon metal instead of permanent magnet. Due to the rare earth, the price become higher and higher. So we use a cheaper one instead of IPM motor.
Mm-hmm.
Yeah.
So there's no rare earth metals in this motor, and there's nothing magnetized in it.
Yes.
Okay, it's just iron.
Yeah, it's just pure wire and silicon.
Okay.
Or iron.
Mm-hmm.
Yeah.
Okay, so can you explain how the controller drives the motor for us then with the 6 wires?
Okay. As you can see in this figure, there are 6 spares, MOSFET and BIOS to drive this SR motor. Mm-hmm. And in this picture, there are 6 stators around the motor, and the rotor is a 4-pole rotor.
Okay.
Okay. Then you to magnetize this space, and in the middle of the rotor, the 2 poles will attract by this wire.
Okay.
Yeah. Then the next step is magnetizing these 2 bases. Then the near one will be attracted to here.
Okay, and that begins the rotation.
Yeah, just like a state motor.
Mm-hmm.
Yeah.
Yes. But you need 6 stators in order to initiate the motion and keep it going, because there's no inherent magnet.
Yeah. Yes.
Okay. Okay, so how does the torque of an SR motor compare to a standard AC permanent magnet?
In normal motor, IPM motor and SR motor, their size is the same. Their torque performance, SR motor will be smaller than IPM motor. But we can do some method to improve the SR motor's torque. So basically, their torque will be the same.
Okay. Yeah. And then your company actually doesn't sell end components like this controller on the market.
Yeah.
You actually make the components that go inside for other companies to use.
Yes.
So like IGBTs and okay.
Drive.
Mm-hmm.
Yeah. And
okay.
we also provide a solution to customers.
Mm-hmm.
Yes.
Okay. Okay, and can you demonstrate your test bench here for us?
Okay. Now this demonstration is SR motor is the main driver, and the IPM motor is a generator. And we use the pedal, the knob will add IPM motor. And you can see this waveform is generated from IPM motor.
Okay.
And the torque performance. Currently, the speed is around 1,000 RPM, and the torque is 2.37
Okay.
meter. Yeah.
Yeah.
So this demonstration is just like a torque control.
Okay. All right. Well, thank you very much, Tim. Appreciate it. Okay. Okay, so we're now here at the Rapid Tech booth, which is a distributor for Sevcon controllers. So I thought I would visit with Sevcon and see what their plans are. They've got some parts on display here in the window. And we're going to meet David, who's works for Sevcon. He'll give us an introduction, and then we'll talk with Todd on some of the technology issues. Okay.
Hi, yeah, my name is Dave. Just a brief introduction into Sevcon and some of the products that we do. This is our latest range of AC controller called Gen 4. The family comes in different sizes. We have a size 2, a size 4, size 6, size 8 and size 10. This is a size 2 controller. Typical application would be a small on-road EV vehicle such as a Renault Twizy, or maybe one of the performance bikes or scooters. The next size, the voltage range on our low voltage products, which is size 2, 4 and 6, ranges from 24 volts up to 72 volts and up to 650 amps peak. Our higher voltage offerings are size 8 and size 10, which range from 100 volts to 300 volts and a 300 watt controller peak.
Okay, and I see them over in that cabinet. Yeah, they're much larger units, more higher voltage, higher power. Yeah.
Higher voltage, higher power, typically used on-road cars, like your saloon cars, and maybe some bus applications. One of our latest products is a HVLP, high voltage, low power controller.
Okay.
And that's typically going to be aimed at the agriculture market for the utilities that hang onto the back of the tractor, and also maybe for some auxiliary equipment on buses such as air conditioning units and pumps. Okay,
and then when you get into that size controller, you start doing water cooling in the block to dissipate the heat.
Exactly, yeah. But both the size 8 and size 10, the size 8 you can buy in two options, either air cooled or water cooled. To be perfectly honest though, not only one of our customers is taking up the air cooled. Everyone's going for it's actually glycol.
Okay, yeah, sure. Yeah.
But once you get to that sort of size and power, you definitely need some form of liquid cooling.
Yes. Okay, well thanks for that. Maybe we can have Todd come over and show us a demonstration of the system in operation. Okay, now we're going. Yes.
High. Speed will more high.
Yep. Works just like we would expect. Okay, so you've got a. Is this a CAN bus based throttle pedal?
No.
No. Okay, it's a.
It's not a CAN, but we have a CAN touch pedal.
Okay, so the Sevcon can read both CAN bus throttle and either voltage or voltage throttles, single or dual channel.
Yeah.
Okay.
And you can see this. This is the Sevcon CAN communication to the display.
Okay.
And the battery message to the controller.
Okay. Great. Can you push the throttle again, and we can watch the CAN bus monitor and see how it works? See if we get the glare on this. Okay, so now we're in drive. Okay, I see the speed coming up and the motor's turning. We can see the bar gauge coming up here. We're at 2 amps, 18.6 volts on the battery. And this is being driven all by CAN bus data flowing over the bus. Okay, great. Okay, and do you have any future plans for new controller models or new applications that you're shooting for?
We do, yeah. As I say, at the moment, the controller range we've got a size 2, 4, 6 and 8 in our development plan. We're very soon going to have a size 9 controller, which just sits in between the 8 and the 10, obviously, and a size 7's on our roadmap as well.
Okay.
And what we're also finding as well, we're getting some requests for integrated product. So integrated motor and controller, and also integrated controller with DC-DC converter.
Right.
We're starting to see a lot of requests.
Yeah, DC to DC converter is always a bit of a sore spot. We've burned a lot of those out. They're very delicate, and you got to make sure it's specified right for your system.
We do a range of DC-DC converters. It's only 300 watt maximum at the moment.
Okay.
But these are a very reliable product for Sevcon. I think last year we sold over 100,000.
Oh wow.
And we don't get any back.
Okay. And they're your own design?
Our own design.
Okay.
Yeah.
And where's your engineering team based?
The engineering team is actually based in Gateshead in the United Kingdom.
Okay.
But we have manufacturing facilities in Juarez,
Mexico,
Poland,
yeah,
and also in Shanghai.
Okay. Great. Well, I was very happy to see you here. I know Jack's been interested in testing and working with some Sevcon controllers, so this will be a big help. Great, thank
nice
you.
To see you, mate.
Okay. Okay, here's the big surprise. As I was walking around, I discovered the China Aviation Lithium Battery Company booth, old friends of the show, and I made an appointment to meet with Sherry Wei, who's the General Manager of International Business for Cal Worldwide. So let's say hi to Sherry. Hello, Sherry.
Hi.
Say hi to all the EVTV viewers.
Hi, EVTV.
We're all big fans of your batteries, and I notice you've got the new CAM series batteries on display here. So can you tell us a little bit about the new batteries and why they're an improvement over the CA series?
Okay. Since our batteries are very good for the electric vehicles, so the main application for this battery is the EV. The customer's requirement, they want to pursue longer distance per charge. And that's why we designed the new model, which is the metal case of the batteries, which can improve the energy density 20% compared to the second generation batteries.
Okay, so by switching from a plastic shell to a very thin, is this aluminum or steel? Aluminum. So a very thin aluminum shell, you've increased the energy density by 20%. That's outstanding. Very, very, very important for the industry. And right now you've got the 72 amp hour unit in production?
Right. The 72 model is kind of started mass production and delivered to the market already. And the other models with different functions, they are still doing the final test here right now.
Okay.
Like the 25P, this model. This one we call that power battery, which means this battery can charge and discharge with full C rate all the time, and to 20C maybe like 10 seconds.
Okay, peak discharge, yeah. 20C peak discharge. Wow.
Right.
Okay.
But it's still on the design right now.
Okay. Now I know that Keegan sent Jack some of the 72s for testing. He's got them in the battery test lab now. And what other sizes of capacity do you plan to sell in the CAM format?
Well, this is 50. 50. This model is kind of with a very low cost because we want this model to be used in the telecom industry for the signal tower base. So for that application, the customer requires very low cost. So this is the low cost battery, and this one is 80 amp hour. It's also for the passenger cars, buses.
Okay. Now I know the 100s and the 180s are very popular with the EVTV viewers. Do you plan on having the larger capacity ones in the future? Yeah, the CAM.
So far, we don't.
No plans for that. Okay. So we're going to have to base our designs in this form factor and this capacity.
Right.
Okay.
25, 50, 72, and 80.
Okay.
That's for the these future 2 or 3 years.
Okay. And are you going to continue producing and selling the CA series for those people who are comfortable with that.
Right.
Okay. Good. Well, thank you very much. This is going to be a highlight of the show for everyone. So I thank you for your time.
Thank you.
Okay. Bye bye.
Bye-bye.
This part of the show floor is all about motorcycles and motorcycle parts, and the booths are much more professional and with fancier products. If this was Thailand, I'd be afraid that they were dudes. So it looks like John Wayne is still alive and well and making motorcycle accessories. So this is the indoor test area. Zero pollution vehicles. You can do this kind of thing. Number of different vendors with scooters and electric bicycles. So, Visionary Dynamics. It's about the same size as my Honda scooter back home. Looks pretty straightforward. Big hub motor. Okay, thanks. Empty and full. Still has a gas tank gauge. Here we go. Wow. Very smooth. Absolutely no sound. Strong brakes. Good pickup. Go around one more time. One more. It's really well balanced, maneuverable. Very fast. To wrap up the video, I thought I'd show you what life is like on the roads of Thailand. Thailand's actually number 3 in the world in per capita road deaths, just behind Libya and Eritrea, so it's very important to be an extremely defensive driver around here. But then some days you see something like this, and I was taking my friend Sean up to a winery and a waterfall near the Myanmar-Thailand border, and we met our new friend. As you'll see, Sean is not afraid of elephants, and everybody had a good time. And on the way home we saw him again, coming the other way, and he actually looked right at me and raised his trunk up as if to say, "Hey, good to see you guys, have a nice day."